Hello everybody and welcome back. So in today's video we're going to be going through a fairly difficult coding interview question. Now I've been doing a few of these on my channel. Let me know in the comments down below and by leaving a like if you guys like this kind of format and what I'm doing and you want more of these videos, because I'm always happy to do them. The platform that I'm going to be doing this problem on is called algoexpert.io. This is personally my favorite way to do programming problems simply because, and I'll show you when we load this up here, it's really easy to have a look at your raw output to see your different test cases to make sure that you got everything correct, rather than trying to find, some questions online, doing them, not knowing if you got them right, having to type in the input. This is just much easier, it's much faster, it's much more convenient, and they have some structured questions ranged by difficulty, so you kind of can work up and around. Anyways, I don't know, I like it. A lot of these questions you can find online, but being able to work in a platform like this helps me focus and just get more done. So if you guys do actually want to use this platform, there's 85 coding interview questions as well as some other resources on here related to interview prep and just some advice. I do have a discount code in the description, so it's Tech with Tim. That'll give you 15% off if you click that link if you are interested in purchasing that, and that is an affiliate link, so I will get some commission from that. So anyways, the problem we're going to be solving today is the largest range problem. So this is one of the free problems under the hard section, so I've decided to skip this one for now. We might go back to it later. And what we're going to do here is just solve this problem. So essentially, I won't read this whole thing, but what the problem is asking us to do is find the largest sequence of consecutive numbers inside of a list. Now, these numbers do not need to be right beside each other, so left or right, they don't have to be adjacent, they just have to exist. So in this case, it's telling us the largest range of numbers, or sequence of numbers, inside of this list is 0 and 7. So 0 is the starting point, 7 is the ending point. That means we know that 1, 2, through 6 are all in this list, and that's the largest sequence of numbers that we found. So how can we go about solving this problem, and how can we solve this problem in optimal time? The initial solution that a lot of you will probably think of when you hear of a problem like this is, why don't we just sort the list? Now, this is okay in some situations, but we have to understand that this is not an optimal solution. The reason this isn't optimal is because we want our code to run in the shortest amount of time possible. And sorting a list already takes n log n time, so that's the average time or worst time for sorting a list. Is there any way that we can do this faster without needing to do a sort? Well, the answer is yes, and I'm going to bring out my drawing tablet and we're going to get into the solution that I'm going to go through for this problem, and then we'll code it out and we'll talk about exactly how it works. So the way I'd like to start by explaining a problem is just breaking down what the problem is, thinking about some trivial solutions to that problem, how we kind of use that solution to find the answer, and then adapting that to find a more optimal solution. So in this case, we're going to do a quick example where I'll just write a few numbers here. They're just going to be random, different from what we had before. Just 2, 1, 0. Why not something like that? And we're just going to see, how would we go about solving this? Well, as a human, what we're going to do is just look for, the largest range of numbers. And in this case, we can tell it's going to be 1, 2, 3, 4, 0, right? We know that that's the range. How can we do this in computing really easily and really fast? Well, a really easy way to do this is to start by just sorting all the numbers. So let's say we sort all the numbers and we go 1, 2, 3, 4. There's a 0 here, my bad. 7, 11. Well, now we can tell why this is so much easier, because since all the consecutive numbers are beside each other, all we need to do is start at 0, loop through the list until we get to a point where there's no consecutive number. So right here, take all of these, store them, save them, be like, okay, this is our current longest range. And now we're at 7, and now what we can do is loop through and find a range from 7 and just keep going until we've gone through all of the numbers and we've determined what the longest range is. Pretty straightforward, pretty easy. I'm sure, most of you guys could come up with how to solve that. So let's erase this, and that's fine. But the issue with that solution is that runs in n log n time, because we need to actually sort the list first, and well, that just takes a lot of time. Is there any way that we can do this without sorting the list? Well, I'm going to walk you through my kind of solution, which is also the solution that the Algo Expert guys use, and you can see it here, and we'll code it out in a second, that runs in linear time, that doesn't require actually needing to sort the list. Now, the way that we do this is using something called a hash table. Now, a hash table in Python is the same thing as a dictionary, but I'll just call it a hash table here because that's kind of the more formal term for it. What I'm going to start by doing is loading all of these numbers into a hash table. Now think to yourself, why I might do this while I write out these numbers. Why do I want all these numbers in a hash table? What's the point of doing this? Like, why am I doing that? Also, what am I going to use as the key? Well, in this case, I'm going to use 0 as, sorry, not the key, as the value for all of these keys in my hash table, and ask yourself, why I might do something like that. Why would I use the number 0, or maybe false, or maybe true? Why might I use that as the key? Well, the whole point of storing all these numbers in a hash table is one-time lookup. Now, what I mean by that is trying to find if any element exists in a list is going to take you n time. The reason for that is because you need to look through all the different elements in the list to determine if a specific element exists. However, looking up an element in a hash table runs in one time. And that's exactly why we're going to use it. Because what I'm going to do is simply start at a number, go left and go right from that number, so go 10, go 12, and just count how many times and how far I can go until I reach a point where none of those numbers are in my hash table. Now, I know you're still confused right now. We're going to go through, obviously, a detailed example and explain it. But what we're going to have kind of in our program is we're going to be keeping track of a left and a right. Now, the left and the right are going to keep pretty much say what the left number in our sequence is and what the right number in our sequence is. And we're going to adjust these to reflect the largest range as we go through these numbers. Now, we're going to start with left equals 0 and right equals 0 because at the very beginning, our largest range is just one number, which is the first number in the list. And that's merely because we just don't know. We haven't looked through it yet. That's the default value. So what my kind of algorithm is, what I'm going to do is I'm going to look at each number in the list. So we're going to go through n times through the list. And what I'm going to do is I'm going to create a left pointer and a right pointer, which are equal to the numbers directly above and directly below 11. So in this case, 12, and in this case, 10. And I'm going to continue branching this out, so to the left and to the right, until I reach a point where the numbers here are no longer in the hash table or don't exist in this list, right? So the basic algorithm is look to the left, look to the right. So I'm going to look to the left, and I'm going to see if 10 is in my hash table. Now, in this case, I go through, I look at my hash table, that 01 lookup time doesn't take any time at all, and I don't see 10. So what I do is I say, okay, we can't go left from 11. There's no more numbers left in the sequence from 11. Let's go right, and let's look at 12. Well, now we're looking for 12, and obviously we look in this hash table, we don't see 12. So what do? We say, okay, we can't go right. And what this means is now we've visited 11, we've looked at 11, and we've determined that the largest sequence that 11 will be a part of is going to be just itself. And the reason we can say that definitively is because if there was a 10 or if there was a 12, then we would have found it, we would have seen it in the hash table, and we would have been able to determine that, okay, potentially 11 could be in a longer sequence. But here, since there's no 10 or there's no 11, no matter what, the largest sequence that 11 can be in is itself. So what we do now is we go down here to our hash table, we find 11, and we mark it with lil 1. Simply saying that we've looked at 11 so far. There's no point in looking at 11 again. We've already done it. Now, this isn't super important for 11, but you'll see why we mark this in a second. Now, we'll go to 7, and we'll kind of speed through this now because I think you're getting the hang of it. And we'll do the same thing. We're going to look left, so for 6, and we're going to look right for 8. Now, in this case, we don't find either of them, right? So same thing here. What we're going to do is, well, we know that 7 cannot be a part of the sequence. So what we're going to do is mark a 1. Now, I forgot to mention what we're doing with this left and right variable up here. Well, essentially what we're going to do is when we kind of go left and right, we're going to check if that left and right distance is greater than the current left and right that we have. So in this case, obviously 0, 0, the difference between them is 0. So any two numbers, left and right, are going to give us a larger difference. So in this case, when we had 11, with our first number, we would actually say that the left is going to be 11 and the right is going to be 11 because that's the largest sequence that we currently know, which is just 11. We get to 7, same thing. So 7 is the same length sequence as 11. We know that there'll never be two sequences of the same length, that they're the max sequence, but I can either decide to leave these as 11 or I can put them as 7. I can change that variable if I wanted to as 7. But anyways, let's go to 3 now and explain how this works. So now we're at 3. We've already looked at 11. We've already looked at 7. We've determined that those are not a part of a longer sequence than just themselves. And what I'm going to do now is do the same thing from 3. I'm going to look at 2, and I'm going to look at 4. But in this case, both 2 and 4 actually exist in my hash table. So here I can see 4 exists, and I can see that 2 exists. So what I'm going to do is, since they actually exist, I'm going to mark them as the fact that I've seen them. And I'm going to say that currently now, at this point in time, my left value is going to be 2 and my right value is going to be 4. My temporary left and my temporary right value is going to be 2 and it's going to be 4. And the reason it's going to be that is because that's currently where I am on the left, and that's currently where I am on the right, and that's the current sequence that we have, 2, 3, 4, right? Okay, so now we say, okay, well, we found 2 and we found 4, so let's try going both ways again. So let's try going to 5, and let's try going to 1. Well, obviously we know 5 doesn't exist, so we're going to end on that path there. That means 4 will stay as our right element. Then we're going to look at 1. Well, now we look in our hash table, we find 1. So what do? We're going to mark 1. So we're going to say, we've looked at 1, let's mark it. So we do that. And then, our left now is going to be at 1, because that is the current furthest left point we have. And we say, okay, well, let's not stop at 1. Let's keep going. Let's go to 0. Okay, let's look for 0. Well, we found 0. It's down here. So what do? We mark 0. We give it a 1. Let's do that. And then all that's left to mark is 3 after that. Well, essentially, we're going to look for -1. We're going to see -1 doesn't exist, so we'll end. We're going to mark 3 as the fact that we've seen it. So let's do this now. And now what we're going to do is we're going to go to the next number. So all this, we can cross that out. We've just done 3, we've done 7, we've done 11. Now it's time to do 4. But the thing is, we don't need to do 4 because we've already determined that 4 is a part of a sequence. We've already determined from looking at 3 that 4 is a part of a sequence. So we don't need to do 4. So what we're going to do is check if 4 is marked as 1, if we've seen it, if it's a part of a sequence already. And if it is, well, what we're going to do is skip it. And same thing with 2. We're going to check, is this a part of a sequence? It is already. We have it marked. It has a 1. So let's skip it. And then we're going to look at 1. And we're going to say, okay, well, 1, that's in there. It's marked as a 1. So what we'll do is we'll skip it. Same thing with 0. And now we're at a point where we've determined that the longest range is actually the left value of, in this case, I guess, 0. And the right value of, 4. And that is our longest range. Now you might be getting a little bit confused on how we're calculating the longest range, but essentially all we're going to do is from each number, go as far left as possible consecutively, go as far right as possible consecutively. We're going to keep track of what the furthest left and the furthest right point was. So in this case, we had 0 and we had, 4. We're going to calculate the difference between them in this case, which is 4. So 4 numbers in that sequence. We'll compare that against what our current max left and right value is. And we'll say if that sequence is currently greater than we have, we'll replace our greatest sequence with that. And we'll keep going through all of the different numbers using this hash table to look them all up in O1, and we'll be fine. Now, some of you might be like, well, this seems like an n squared algorithm where we have to look through all the numbers, and then what we have to do is go left potentially unlimitedly and right potentially unlimitedly to n, right? Well, the whole thing here is this actually runs in linear time. And the reason it runs in linear time is because every time we see a number, we mark it in the hash table. So we will only actually ever evaluate a number one time, because every single time that we look at it, even from, going left and going right, that's only ever looking at it once. Because when we get into the for loop and we're like, trying to evaluate 2 and trying to evaluate 1, we see that it's already marked in the hash table, so we don't need to do any operations for it. So we can be certain that this algorithm will run actually in perfect ON time every time, because, well, we don't need to do evaluations on numbers that we've already marked, and, we're only going to mark n numbers. So that's essentially how that works. So anyways, that is kind of the solution. Now let's actually get into programming, and I know this was long, but I wanted to make sure that you guys really understood how this worked and why this does run in ON time. As always, leave questions down below, and let's get into coding it now. Okay, so I made this code box full screen. I'm hoping this is readable enough for you guys, and let's actually just start coding the problem. So essentially, we're going to follow that algorithm that I explained, where we're going to create a hash table to start. We're going to then go look at every single number in our list. We're going to look to the left and to the right of that number. We're going to see how far we can go. We're going to mark the numbers in our hash table, and that will actually ensure that our algorithm runs in ON time. We'll keep track of the furthest left and furthest right point in the largest sequence, and then we'll return that. So what do we need to do to start? Well, we need to create a hash table. So I'm going to create numbers equals this, and I'm going to say x:0 for x in array. Now what this is going to do is simply create a new entry in our hash table that has the value 0 and the key, whatever the number is for every number in our array. So we'll do that. Then I'm going to set up some left equals right equals 0 variables here. So left equals 0, right equals 0. You can do this in Python. It's kind of like a fancy trick to keep track of what our current longest sequence is, or the left point of our longest sequence and the right point of our longest sequence. Okay, and now what we're going to do is we're going to look through every single number in our array. So we're going to say for number in array. And the first step to check is have we already evaluated this number? Is it already a part of a sequence, or does it need to be evaluated still? So we can check that very basically. We'll say if numbers number equals 0, in only that case will we actually evaluate the number. Otherwise, if this is not true, that means that we've already seen this number when we've gone left or gone right from another point, and there's no point in evaluating it again, because we know that, going left or right, we're going to reach the same sequence again because we've checked that already. So we're going to now say if it's not been evaluated, well, what we need to do is go as far left as we can from it and go as far right as we can from it and keep track of those values. So I'm going to say left underscore count equals, in this case, we're actually going to do number minus 1, and I'm going to say right underscore count equals number plus 1. Now what I'm going to do is go as far left from this number as I can, looking it up in the hash table each time, and then I'm going to go as far right and keep track of that. So to do this, I'm going to say while left underscore count, what is it? Sorry, actually, my bad here. Yeah, no, while left underscore count in numbers. So this is a lookup in the hash table, just seeing if it exists. Again, this will run in 01 time, so let's actually write that down so that we remember. 01, okay. I don't know why the brackets aren't. Okay, that would make sense. Anyways, so while this number is in numbers, what we'll do is simply decrement the number and mark the number in numbers. So we'll say numbers left underscore count equals 1. Then what we'll say is left underscore count minus equals 1. So continue to go left as far as we can. Now, once we reach a point where we get out of this loop, we actually just need to add 1 to left count. The reason we need to do that is simply because we start by subtracting 1, and we don't necessarily know if this number is automatically going to be in left count. And at the end, we subtract 1 again to see if the next number is going to be in numbers or in our hash table. So we need to just add 1 at the end to make sure that we're not saying one extra number exists in our sequence when really it does not. Anyways, you guys will see that in a second. Okay, so that's the left aspect of it. We can actually copy this and do it with the right aspect, but I feel like it might be faster just to type it. So we'll say while right underscore count in numbers, then we'll say numbers, oops, this, and I guess I need a colon. So we'll say numbers right underscore count equals 1, and then right underscore count plus equals 1, if I could type properly, and then we'll say right underscore count minus equals 1, and this needs to be plus equals 1 as well. You guys can tell I'm a little tired this morning. Apparently I keep forgetting all this basic stuff. Okay, and I have this cursor in the wrong mode. Okay, so anyways, there we go. We have right count and we have left count. So what we've done now, just so everyone's on the same page here, is we've initialized two variables, left count and right count. Our left count is going to go to the left, our right count is going to go to the right. Again, keeping track of the consecutive numbers from whatever number we're at. So let's say we're looking at the number 4 in our array. We're going to check, is 4 marked? Have we looked at 4 yet in our hash table? We haven't. Okay, so we'll set up our left count to start at 3, our right count to start at 5, and now we're going to check, is 3 in numbers? If it is, what we'll do is we'll mark that number, and then we'll check now if 2 is in numbers, and we'll keep doing that, right? As soon as we break out, what we'll do is say, okay, well, we checked 2 wasn't in the number, so let's just add that left count back up 1, because that's the last number that we knew for sure was in the range, right? Now, same thing with the right count. We're going to check if, in this case, 5 is in numbers. If it is, we'll mark it, we'll add to the next one, then we'll check if 6 is in. Otherwise, what we're going to do when we break out is just subtract 1, so we have the correct range. Now, what I'm going to do is actually set the largest range aspect here, so I'm going to say if right minus left is less than, in this case, right underscore count minus left underscore count. And I'm actually going to do a less than or equal sign here, and we'll talk about why in a second I want to do that. Then what we'll say is right equals right underscore count, and left equals left underscore count. And then we will simply return at the end here an array with left and right. Now, I know I kind of ended this, kind of fast here, and I'm sure some of you guys are probably still figuring out what's going on, but essentially this is all that we need to do to actually make this work. Now, we'll run through it one more time, with an example here, but let's talk about this part, what this is doing. This is going to check to make sure that the current range that we've just found by going left and going right is larger than the last previous range that we had kept track of. So in this case, the first time you run this will always be true, because obviously, your number won't be marked that you're looking at, so the first number won't be marked. Then what you're going to end up doing is say that left equals right, and these will be the same value if there's no, sequence from the first number. So if you say left less than or equal to. Then what we're going to do is keep track of all these sequences. So maybe we find a sequence of length 2. Maybe that sequence has the numbers 1, 2 in it. We'll say left equals 1, right equals 2. We know that how many numbers are in that sequence by subtracting the right pointer from the left pointer. So in this case, gives us 1. And then we check if the current sequence we found is greater than or less than that sequence. And that's pretty much all that we need to do. And in that case, we mark right and we mark left, and there we go. And yeah, I'm fairly certain that that's all that needs to be done. I'll check to make sure. And yeah, I'm going to go ahead and say that that's okay. So let's actually run this code. So how do I get this out of full screen mode? Okay, so run code, give it a second, and we can see that we pass all of these test cases. So let's compare it to what solution they had. So their solution is very similar. So you can see they have a best range, nums, longest length. I think they've made it a little bit more complicated than it really needs to be honest, in terms of the way that they programmed it. But I mean, you guys can be the judge whether you like my version or their version better. Anyways, that is the problem. Now, if we look here, we can see some of the hints that it was trying to give us. So you can use a hash table, which obviously we did. Iterate through the input array once, storing every unique number in a hash table, which we did. Then optimal space-time complexity, on time, on space. And that's exactly what we're doing because, well, we're keeping on space here. Well, we need this hash table for every number in the list. And then for here, this is simply on. We know that this will ever only run n times. So in theory, we could say this is n plus n. And obviously, that's going to be 2n, which is going to simplify to n. So anyways, that has been it. If you guys do like Algo Expert, honestly, I'm telling you guys, I've used this. I'm really not just trying to sell you a product. This is a great platform. If you want it, take advantage of the discount code. It is the link in the description. And I will be honest with you guys, this platform has been getting more expensive. If I go to the purchase, it used to be $77. It's $85 now. And I can only imagine in the future, it will continue to rise in price as they add more questions, as it seems to be that how many questions they have, they charge $1 for each question. So anyways, that has been it. I hope you guys enjoyed. If you did, leave a like, subscribe, and let me know what you guys want to see in the future.